Hello all, I am Shatabdi Acharya from Vedang Institute of Technology. So in the previous video we were discussing about carbocation, carbanion and free radical. So in this video yes, we were discussing also about the reactivities of the reagents. So in this video we will carry it forward to discuss the factors which are responsible for the reactivity of the substrate and the reagents. Okay. So there are basically electronic factors which are responsible for the reactivity, and that electronic effect can be broadly classified into two categories. One is primary effect and the one is secondary effect. Primary effect is like observable. It is present in almost all the molecules, and these are not so important. Basically we are having two primary effects. One is electronegativity and the one is size of atom. So if the electronegativity is high, then that atom will basically draw the electron pairs or shift the electron pairs more towards itself, carrying a negative charge over itself and the positive charge over the other atom from which it has drawn its electron density. Right. And how does size affect? Basically size effects are based on the distance from the nucleus. Distance from the nucleus. So if distance from the nucleus is more or greater, then what happens? Then the nuclear hold on the outermost electron will basically decrease, as a result of which the nuclear pull or the electronegativity will decrease. So basically these were two minor factors on which the primary effects on which the reactivity or the electronic effects were depending. But there are very important secondary effects which are inductive effect, hyperconjugation, resonance, mesomeric effect, aromaticity, ortho effect, SIP and SIR. So these are very important and highly dominant effects which we have to learn in organic chemistry for understanding the concepts better. So we'll start up with inductive effect. And in the upcoming videos, we will take up each effect individually. So basically what happens in inductive effect, suppose let us assume there is a carbon atom, it is connected to an atom X. The carbon atom is connected to the atom X. Now, if that particular atom X is highly electronegative, if that is more electronegative than the carbon atom, so what will happen? The electron pair, the electron cloud which was uniformly shared between these two atoms, will that be uniform now? Obviously not, because X is more electronegative. X will withdraw the electrons or pull the electronic cloud more towards itself. So as a result of which, what was happening? The bond or the electron cloud which was similar or parallel and equally shared between both the atoms now becomes distorted, like it is shifted more towards the highly electronegative atom. It can happen the other way around also. If carbon turns out to be more electronegative than our atom X, then what will happen? Carbon will now pull the electron density more towards itself. Now the electron density will be shifted more towards carbon. Right. So as a result of which what happens? The bond which was shared between carbon and the other group, that is not breaking as a whole. But instead of that, what is happening? The electron clouds are shifted more towards one particular atom, as a result of which that particular atom gains a partial negative charge over itself due to the withdrawal or the closer approach of the electron clouds to that particular atom. That atom has a delta negative charge over itself. Okay. So if I'm seeing this case, what will happen? X will have a delta negative charge, and as the electrons and densities are moving away from carbon, then what will happen? Carbon will have a delta positive charge. So as a result of which there will be a development of a dipole in this, because the bonds are not breaking, but the electron cloud is just shifting towards one particular atom. Okay. So I can say due to the shift of electron cloud towards the more electronegative atom, there is a development of dipole. Okay. As a result of which what will happen? Suppose let us assume I am assuming that carbon is connected to other carbon atoms X. Okay. So here X was drawing the electron density towards itself. So X was having a delta negative charge. Carbon developed a delta positive charge. Due to its deficiency, now carbon will try pulling the electrons from this bond. Okay, its bond with the another carbon atom. It cannot pull back its bond from like electrons from the X, because X is more electronegative atom. So what it will do? It will try pulling the electron density from the next carbon atom. As a result, there will be a delta positive charge again over that particular carbon, but that charge will be very feeble, because as such there is no electron density, sorry, there is no difference of electronegativity between two carbon atoms. But as a result of this particular atom, an electron or electronegativity is induced over this particular carbon, as a result of which it turns out to be slightly more electronegative than this particular atom, this carbon, and it try pulling the electrons from that carbon atom. Now this carbon, again, what will happen after this first carbon has pulled electron density from the second carbon will also become more electronegative as compared to the third carbon, but lesser in magnitude. So gradually we see, as we move in the chain, the magnitude of inductive effect is gradually decreasing. And what happens? Generally after carbon number 2 or 3, this effect dies out. Okay. After the carbon number 3, this effect is dying out. It is not at all observed. So this effect, the induction of polarity over the carbon atoms in the chain due to the presence of a heteroatom or a more electronegative or a less electronegative atom attached to it, that effect is called inductive effect. Now, that particular group which is attached to carbon, it can be more electronegative, it can be less electronegative. If it is more electronegative, then it will pull the electron density towards itself, it will build a negative charge on itself, and that's how that particular group comes to be known as a minus I effect group. Means a particular group which withdraws electron from the carbon chain and acquires a negative charge on itself. If that particular group is pulling electron clouds from carbon and acquiring a negative charge on itself, that will be called a minus I group. If X is pulling electron, then X is my minus I group. Got it? Now, if there is another group, suppose again X, but here carbon is more electronegative than that particular group, then carbon will pull, we are saying carbon will pull electron density from this bond. I can say it otherwise, that X will donate electrons to carbon. Okay. So if a particular group is giving or donating its electron to another atom, then it will build a comparatively positive charge on itself. So if a group is building a positive charge on itself, that is called as a plus I effect group. Okay. So the plus I or minus I effect is basically depending upon the nature of the group. If the nature of the group is highly electronegative, what it will do? It will pull the electron density from the carbon towards itself. It will gain a partial negative charge, and that's how that group comes to be called as or known as a minus I effect group. If a group is donating electrons to the carbon chain, then what happens? It basically comes out to be deficient in electron, and that group comes out to be known as a plus I effect group. Okay. Now, depending upon the nature, we have classified groups into plus I and minus I group. There will be a possibility as of strength of donation. If the group is more electronegative, then a strength of donation or the strength of pulling. Okay, strength of basically minus I or plus I effect. Okay, so if the group is highly electronegative, then it will pull the electron clouds towards itself more strongly. Okay, then that will show a minus I effect stronger. Okay, it will show a stronger minus I effect. But if that group is electronegative but not that strong, then the minus I effect will be gradually smaller. So we have an order for deciding the strength of minus I effect, and I have written it down for you. The highly electronegative one is the nitro, after that fluorine, COH, chlorine, bromine, iodine, hydroxide, OR, C6H5, and then hydrogen, and all these are written down in reference to hydrogen atom. Okay, so these all you can find any mnemonics for remembering that, or easily it can come with practice. Okay, the number of questions, more the number of questions you practice, more you get cleared on the concepts, and more it will be easier for you to understand this. You don't have to mug up this basically. So the strength of minus I effect is shown in this particular order. Now if I'm seeing the strength of plus I effect, then number of alkyl groups. Basically, remember, alkyl groups are showing stronger plus I effect. So if the number of alkyl group is more, the strength of plus I effect is more, the strength of electron donation is greater. Okay, so the order is 3 degree, 2 degree, 1 degree, and then methyl group. Now there is also another possibility if you are getting different type of isotopes. What are isotopes? Different form of the elements with the same atomic number and different mass number. So if I say hydrogen, it is having 3 isotopes, protium, deuterium, tritium, and its formula is H11 for protium, H12 deuterium, H13 tritium. Same atomic number, different mass number, right? So heavier isotopes show greater inductive effect or greater plus I effect than lower isotopes. So if I compare the strength, then tritium is highly showing greater plus I effect than deuterium and then like protium. Okay. So this is basically the order, and you have to remember this series. Now the important concept comes here is, if suppose you are having two compounds where there are multiple number of like groups, okay, multiple number of hetero groups attached, then how you will determine which will be the dominant factor in deciding the inductive effect? In that case, you have to remember the first priority you have to give is the distance of the group from that atom. Okay, the distance. Then the next priority will be number of groups present, then the power of the group. Okay, the power basically comes from this order. You have to remember this order, and this order is the power of the group. So the first priority you have to give here is the distance of the group from that particular element or that particular center. Okay, the center where the inductive effect originates. So the distance of that group, like any group from these, the distance, then the number, and then power. Okay, if you're not understanding right now, don't worry. In the later slides, I have questions prepared for you to determine the, like, have questions on inductive effect like usually you are facing. In that, you will be clear. Next is, we have to deal with the application of inductive effect. This is very important. Here we have to deal with application of inductive effect. But one more point to note here is, inductive effect is a comparatively permanent effect. Okay, because carbon is attached to that X atom. That X atom is a part of the carbon chain now. Whether it is more or less electronegative, based on that we will decide its plus I or minus I effect. But this inductive effect is a permanent effect, but this is a very feeble effect. Okay, its effect is very feeble. If there are some other stronger factors arising, then this effect can also be neglected and they can supersede this effect. Okay, so inductive effect is a permanent effect but a feeble effect. Okay, weak effect. Now, to determine the application of inductive effect, we have basically two different applications, or we can classify the applications into two broader heads. One is to compare the acidic strength and to compare the basic strength. Okay, so if we take the example to compare the acidic strength of carboxylic acid. So in order to determine the acidic strength of carboxylic acid, you have to keep certain things in mind. First is, the stability of anion is directly proportional to the acidic strength. Greater the stability of the anion, more will be the acidic strength. Why anion? Because acids means they are H plus donors, right? So after the H plus is being lost from the metal, the compound, what is left behind is a anion. So if the anion is more stable, then I can say the acidic strength is higher or the greater. If a compound knows after losing H plus, I will reach to a point where I will be very much stable. Everybody wants settlement, everybody wants stability in their life. So if there is a compound X, and the compound thinks that after losing H plus atoms, I will come to a state where I will be stable. Then obviously happily it can give its H plus. But if the atom can foresee that after losing H plus, I will be in a very unstable situation. So will that atom lose H plus ions ever? Obviously no. Then I can say that the acidic strength will decrease. So if the compound after losing H plus goes to a stable anionic form, then the strength of acid will increase. So stability of anion is directly proportional to the acidic strength. Now acidic strength will be directly proportional to the minus I effect of the group and inversely proportional to the plus I effect of the group. What does that mean? Minus I effect means any group which has the tendency to take up electrons. Okay, it has a tendency to take away the electron, it is more electronegative in nature. Therefore, it can attract that electron pairs towards itself, developing a negative charge over on it only. Okay, that is a minus I effect group. So if suppose imagine a situation, you are having like some problems, you are in a lot of problem, you have a friend which to whom you can share everything. Okay, you have a friend like very dear to you, very trustable friend of yours. To that friend you can share whatever like insecurities or whatever bad feelings you are going on, you can just vent out in front of that friend. Then what will happen? Initially you were having negative charge, you had a friend who had a tendency to soak up your negative charge. Your friend had a tendency to take up your negative charge. Then as a result of what will happen? You will become comparatively stable. If you are in tension and you are having a friend who is constantly ranting in front of you, obviously you will face like your negativity will increase, you will become more unstable. So any particular atom, if like after losing electron, it will lead to a compound where it is having a friend to whom it can share its negative charge, then it will be more stable. And that friend is a minus I effect group, because minus I effect group had a tendency to take up electrons or take up negative charge on itself. So if an atom loses H plus, becomes an anion, but when the atom looks back, it knows that I have a particular group in my compound which can take up my negative charge, which can share my negative charge. That negative charge is not belonging to me. I have friends with whom I can share. Then in that case, the strength of acid will increase. And if the compound sees that after losing H plus, I am having like such friends in my compound, those are all like donating electrons to me, they are only giving tension to me, then of course at no any cost will I be able to form an anion. Why I will take the risk of forming a negative charge when nobody is there to balance me? In that case, what will happen? The strength of acid will decrease. Therefore, acidic strength is directly proportional to the minus I effect and inversely proportional to the plus I effect. Okay, so we will see some questions based on this acidic effect. The first is, compare the acidic strength of CH3OH, CD3COOH, Ci3COOH. Now here the acidic proton or the acidic part will be this COH is the acidic group, and the acidic H plus which will be lost is this hydrogen. Now what we have said is in the previous slide we have seen heavier isotopes show greater plus I effect. Now here the case is about that only, CH3, CD3, CT3. So what is the heavier isotope? T. It will show greater plus I effect. Now plus I effect means it will donate its electron. So this particular T is that selfish friend who keeps on ranting about his own struggle, right? So here the carboxylic acid sees, if I'm losing H plus, when the carboxylic acid is looking back, the carboxylic acid is thinking, oh, I have like tritium in my atom. So if I'm losing H plus, then this tritium will bother me a lot. This tritium will not share my negative charge. So I will not give my proton. Like extracting a proton from this complex will be, or this compound will be very difficult. But if I see COOH, in case of CD3, then COOH will think, okay, I have a middle, like intermediate isotope. It can somehow balance my negative charge. So compared to CT3, CD3 will lose its H plus more easily. Now, if this is saying that this particular COOH is looking back and saying, okay, I have the simplest isotope, protium, and protium is very chill kind of friend. Whatever negative charge I'll be having, this protium will take away from me. I will not be like, I'll be more relaxed if I'm bonded to this H isotope, basically the protium isotope. So for this COH group, losing H plus will be very easy. Yeah, there is a group which can balance my negative charge, so you take my H plus, right? So if I compare the acidic strength, highest acidic strength will be shown by this CH3COH, then CD3COH, then CT3COH. Okay. The next question, you have to compare the acidic strength between of these three. Okay, here in the COH you are having an iodide group or iodine group. So iodine basically shows a minus I effect. Okay, iodine basically being a halogen, it withdraws electron density towards itself. So it has to, now here you are seeing all the atoms which are substituted is of iodine, I'm sorry, this is iodine. Okay, in all the three cases you have iodine as a substituent. So what you will see, now here comes the case of where I have given you in box in the first case. You have to compare distance, number and power. Okay, so here the dominating factor will be obviously distance, only one factor is applicable, I guess. Yeah, distance. So here I'm seeing the iodine is in the maximum distance from the COH group. Here it's in the middle, but here in the first case, the iodine is in the closest proximity of the acidic group. So in the first case, as soon as H plus is lost, carboxylic acid sees, yes, I have iodine very near to me. The iodine will immediately take up my negative charge and stabilize me. So in all the three cases, this particular atom will lose, or this particular compound will lose its H plus very easily, or the most easily, I can say. Now here if I say it's in the middle, intermediate, it will, like, the strength of acid will be so, like basically lesser than the first case. So it will be lesser than that. But if I compare the third case compared to this will show a greater acidic strength, because here the distance of iodine group is at the maximum. So if I need to write the order, it will be like this. And here the dominating factor, or the factor we are considering, is distance of the group. Okay, now the third case, it's an interesting question, I guess. So here I'm having, what groups I'm having? NO2 and 2Cl minus. Okay, both are present in the same group. If I see that order, if you remember the order which I have shown you, this. So we are having NO2 group and Cl group in our question. Now if I had to see the order, then NO2 has stronger minus I effect than Cl, right? So by that logic, NO2 should be more acidic, because it can show minus I effect to the strongest as compared to chlorine. But again, here the factor which plays is the power is placed at the last. So you have to give more priority to the number of groups. By that logic, if I see, I have to give priority to number, then to power. Okay, this is the logic being used here. So NO2, although it is a strong minus I effect showing group, but its acidic strength will be dominated by the second case, where you have number of minus I groups more, or greater number of minus I groups. So if I compare the acidic strength here, then this will be more acidic as compared to this. So basically in acidic strength, you have to take up or deal with, or the concept is, after losing H plus, which anion is more stable, or you have to see, you are hunt for factors which stabilize the anion after H plus is lost. If there are certain factors where after losing H plus, the compound becomes more stable, then that will be more acidic. Now if I compare, if I give you a question, compare the acidic strength of HCOOH, this is formic acid, and CH3COOH. Okay, you have to compare the acidic strength of these two groups, HCOH and CH3COH. Clearly visible. H, here you are having this, the hydrogen is the acidic hydrogen, this will be lost. Now after this hydrogen is lost, here you are having a H atom, here you are having a CH3 atom. So CH3 atom methyl group shows a plus I effect group, and plus I means it will donate electron density to this COO ion, carboxylate ion, after H plus is lost. So by any chance, will this be a stable acid or a stable anion after the loss of H plus? Obviously no, because here there are electron density aggravating factors. So therefore hydrogen, although it cannot pull electrons, but at least it cannot donate electrons. Like my friend who cannot solve my problems, but at least cannot aggravate my problem. There is a friend who listens to me. Okay, although that friend has no solution to my problem, at least he is a way, or she is a way to whom I can rant my, or vent out my problems to that person, right? So that person is hydrogen for this COH, first COH. But here CH3 is such kind of a friend, that the one which cannot neither solve the problem nor silently listen to me. This is the friend who aggravates my problem. So obviously this will lead to the decrease in acidic strength. The name of this acid is formic acid, present in ants, and this acid is acetic acid, present in vinegar. So if I compare the acidic strength, then formic acid is a stronger acid than acetic acid. Okay. So these were some of the concepts or questions on acidic nature of like how to determine the acidic property of compounds. Now in the further lectures, we will discuss the factors in which strength of basic strengths are depending, and we will take up other questions also. So thank you so much for watching this video. In the next lecture, we'll be seeing the other topics. Thank you.